Every question we ask AI opens a challenge. Does it really know or is it just guessing? Now imagine an AI that doesn't just generate but retrieves real knowledge before it speaks. That's RAG. Not a model with all the answers, but one that knows where to look. And that simple shift, it is changing everything from search engines to science labs. In this video, we'll explore what Retrieval-Augmented Generation really is, how it works behind the scenes, and why it's becoming a game changer in AI systems today. What is RAG? Think of RAG as giving your AI access to Google search but for your private documents or internal knowledge base. RAG stands for Retrieval Augmented Generation. It's a method where a language model like ChatGPT is combined with a search engine that retrieves relevant information before generating a response. So instead of only relying on what it was trained on, the model can look up relevant facts from a trusted source before answering. For example, if you ask what are the benefits of your company's new health plan, the AI first retrieves documents like HR policies. Then it generates an answer based on that context. This two-step process makes responses more accurate, relevant, and grounded. Why do we need RAG? Even the best AI models don't know everything. RAG fills the gap between static knowledge and real world changing information. Language models are trained on static data, they don't update on their own. They can hallucinate answers when they are unsure. Sensitive or internal data is not in the public training data set. RAG solves all these problems by keeping the LLM updated using real time or external data, giving the model access to private data sets and reducing hallucination by showing external content. How does RAG work? Let's peek behind the curtain. Here is how your question turns into a smart document aware answer. RAG has two main parts, retriever and generator. Retriever converts your question into a search query, searches through documents or a vector database, pulls the top K relevant chunks, for example, top 3 pages. Generator reads the retrieved information, generates an answer using that information as context. Think of it like Google copy paste explained to me in simple terms. This pipeline enables custom data driven conversations with AI. What kind of data can RAG understand and use? You can feed RAG almost anything, not just web pages. RAG works with PDFs, Word documents, Notion pages, Google Drive files, company knowledge bases, code bases, Wikipedia dumps, and research papers. Any structured or unstructured data can be used as long as it can be chunked and embedded. To understand RAG, you have got to meet its power duo, chunking and embeddings. Chunking is the process of breaking large documents into small pieces, for example, 200 to 500 words. Why? AI performs better with bite sized content than full documents. Embedding is the process where every chunk is turned into a numeric vector using an embedding model. These vectors help the AI measure similarity between your question and each chunk. So when you ask something, the retriever finds the chunk closest in meaning. Why spend weeks fine tuning a model when you can update knowledge instantly with RAG? Let's compare features of fine tuning and RAG to figure out which works better. When it comes to updating a model, fine tuning requires retraining, but with RAG, you can instantly do that with new documents. The cost of fine tuning is expensive, but the cost of RAG is affordable. When we compare accuracy, the fine tuning is good but static, but in RAG, it is good and dynamic. Fine tuning is used to alter model behavior deeply, but RAG is used for augmenting answers with fresh information. Fine tuning changes the model's brain. RAG just gives it new books to read. We have seen what RAG can do, but what's happening under the hood? Let's explore the powerful tools and frameworks that make retrieval augmented generation work smoothly. RAG is not just a single model, it is a pipeline, and every part of that pipeline needs solid tools to run efficiently. Tooling in RAG refers to all the supporting software, frameworks, and infrastructure that help connect the retriever and generator, handle large volumes of documents, search, retrieve, and rank results fast, ensure everything works in real time or near real time. Here are some of the common tools used in RAG systems. First, vector databases. These store documents as embeddings and allow for similarity search. For example, files, spine code, wavelet, and quadrant. Embedders. These convert documents and queries into vector form. For example, OpenAI's embeddings, Hugging Face models, or Coho. Third, retrievers. These decide what information to fetch from the vector database. For example, dense retrievers using encoders like contriver. Fourth tool is generator. These are the large language models that generate responses based on retrieved contacts. For example, GPT-4, Llama, Mistral, etc. Fifth is orchestration frameworks. These tie everything together in a RAG workflow. For example, LangChain, Llama Index. They help define how the retriever and generator communicate. The final tool is chunking and pre-processing tools. Before storing documents, they must be broken into chunks. For example, in this tools, long chains text splitters and recursive character text splitter are used here. So, tooling is the backbone of any RAG system. It ensures scalability, speed, and reliability. If you are building a RAG app, tooling choices can determine whether your system is lightning fast or frustratingly slow. RAG is not just theory, it powers tools you use every day. Let's see some real time examples. Chatbots that answer company specific, frequently asked questions, legal assistants that pull relevant case law, healthcare AI that references medical documents, coding co-pilots that refer to private repositories, search engines that summarize results in natural language. Even ChatGPT with my files uses a form of RAG. Here comes the most important part of this video. You don't have to build retrieval augmented generation from scratch. Today, a rich ecosystem of tools makes it surprisingly easy to plug RAG into your AI workflows, even if you are not a full stack engineer. Let's walk through some of the most popular tools that power modern RAG systems. Each one plays a specific role in that pipeline, from managing documents to generating responses. The first tool that you need to install is LangChain. It is like a conductor of the RAG orchestra. It helps you connect your language model to a retriever, define how the data flows, and manage the logic between steps. If you are building a RAG application from scratch, LangChain is one of the most beginner friendly and powerful ways to do it. The second tool is Llama Index. Llama Index specializes in making your documents LLM ready. It takes unstructured data, PDFs, web pages, databases, and turns it into an index that a model can understand and search through. If your RAG app needs to handle lots of documents, Llama Index is a go to tool. Third tool is Haystack. Haystack is a full-fledged framework for building RAG pipelines. It includes pre-built components like retrievers, readers, and APIs, making it great for production-level applications. It also supports multiple backends and databases, so it's highly customizable. Fourth tool is vector databases. We have many tools and others: Pinecone, Waviate, Fias. These are the backbone of the retrieval step. When you embed your documents into vectors, these databases help you find the most relevant chunks quickly. Pinecone is fully managed and scalable. Waviate is open source and schema flexible. Fias by Facebook is lightweight and great for local and small scale setups. The last tool is OpenAI's API. Finally, to generate responses, you can use language models like GPT-4 through the OpenAI API. It is the part of the RAG pipeline that actually writes the answer, using the retrieved context as fuel. With these tools, you can go from raw data to a smart retrieval augmented assistant in hours, not months. RAG is powerful but not perfect. Let's talk about the rough edges. Even though RAG is a breakthrough in AI systems, it's not without its challenges. If your documents are broken into chunks poorly, the system may pull in irrelevant pieces, leading to confusing answers. Similarly, if the text is embedded using low quality models, the retrieval step itself becomes flawed and the final response falls apart. Sometimes the retriever may fetch too many documents, creating a noisy context where the actual answer gets buried in distraction. There is also the issue of token limits. Only so much text can be passed to the model at once, so important details might get cut off. And despite all this, if your prompt is not solid or the context is not precise, the language model may still hallucinate or fabricate answers. Building a good RAG system is not just about plugging things in. It takes careful design, smart prompt engineering, and plenty of testing. RAG is not just a trend, it is the backbone of the next AI generation. The future of RAG is unfolding rapidly and it is not stopping at text. Imagine a world where RAG becomes multimodal, giving AI the ability to retrieve and reason over video and audio, just like it does with documents. Combine it with AI agents, and you get intelligent systems that can dynamically look up tools, access documentation, and act with purpose. As researchers explore hybrid approaches that mix RAG with fine tuning, we get the best of both worlds, adaptability and deep behavior change. And soon, we will see the rise of auto RAG systems that not only respond to your knowledge base but actively curate, update, and organize it without human input. We are heading toward a future where AI evolves in real time, learning and adjusting through RAG, making it the true backbone of next gen intelligence. Now, you know what makes RAG such a game changer. And remember, knowledge is power, but retrieval power generation is the future.